Hi everyone, today we're going to be talking about a very easy algorithm for me and I think for y'all. It's called the perception algorithm and it works as easy as it is intended because let's say we have two binary classes. Let's also say that they have two different features, weight and the length. Let's graph them. As you may see, the first red class is here, the second green class is here. So everything that the algorithm does, it just fits a straight line that separates those two classes. Everything that is upper than this line is red, and everything that is lower than this line is actually green. But the definition of it, it's a supervised learning algorithm, as you might understand, that is created for binary classification, that fits a line that is separating line for two classes of data when the data is graphed, for example. It works a little different from the logistic regression because it doesn't have a certain kind of a graph. It's not really smooth. It's just a bunch of zeros and negatives, a bunch of ones and negative ones. How it works, we take the same thing as we did in the linear regression. Basically, double the transpose x plus b is the same as x theta, because when we're talking about x theta, we basically intend that there is a certain feature called the bias in the matrix that is always set to 1, and when we multiply it by the matrix of parameters, we basically multiply 1 by the parameter, and then we get the b. But here it's written specifically so you might see it, understand it, create something in your brain that helps you to understand it, to comprehend it. And when it's greater than 0, when the linear sum, I call it the linear thing, let's say like that. When it's greater than 0, it's +1. When it's less or equal than 0, it's -1. How it works? Let's talk about the cost function, because from my perspective, it's the most important thing from all of the model, because we can use gradient descent, gradient ascent, subgradient descent that we will use here. So, like a lot of interesting things we can do with the cost function. So how here it works? The maximum function gives us the maximum value between 0 and this thing. So let's think about it iterationally, because when you see it for the first time, it may seem, I don't know, hard for you. So let's talk about that. Let's say that our model has predicted a value correctly. So let's say y1 is 1, and this thing, as it's predicted a value correctly, look at this, it's greater than 0. So this product is positive. But when it's with minus, it's negative. When you take the maximum, it's 0. Our cost function doesn't change. But the same thing works with when the y is -1, so this thing is less or equal than 0, so we will get a negative number overall, and still maximum, because we take the maximum function from 0, and the negative number would get probably 0, so it doesn't change either. But let's imagine a situation when our prediction is incorrect. So let's say y1 is 1, this thing has predicted -1, so it's lower than 0. How it works, the whole product would be positive. And when we are talking about what is more, a positive number or 0 is always the positive number, so our cost function increases. And if this was, for example, I don't know, like negative 100,000, so our cost function would face a big increase, And let's talk about what we actually use to adjust the model. We use the subgradient descent. It's the same as gradient descent. Don't look at this b thing. Let's just pretend that it's not L but theta. What we do, we take the derivative, but the derivative is kind of interesting, because just believe me that I'm sorry, it should have been plus, I'm so sorry. I mean, the whole derivative would be minus y I x y. And because it's minus minus, here's plus. I'm so sorry about it, but you might understand that when our prediction is incorrect, we basically increase, we basically decrease the function, so it is gradient descent. So you may think about it in terms of iterations. So let's say that y is negative and the x is negative. So the whole thing would be positive, because if we have two negative values and we have predicted them incorrectly, so our function is basically, our line is basically lower than those two values. And when we take minus minus, we take basically plus, so our w t plus 1 increases, so the line increases until it's higher than a certain point. So it's kind of an important thing, because we adjust our algorithm within every point, and you should probably take it through your mind how it works. So let's take a value that, for example, it's positive, y is positive, x is positive, the whole thing will be positive, and probably our line is again lower than this value and is predicted incorrectly, let's say, like that, and we just increase it, and so on and on and on and on. It works like that. I think you understand that this algorithm is extremely important. I'm so tired of recording the 20th time of this video. I'm so sorry about not posting a lot of videos. So that's everything. I hope you like that, and I hope you maybe leave something in the comments. I don't know.